Hey everyone, welcome to another Open Cluster Management Community Meetings. Today is March the 15th, 2024. On the agenda today, or later on, we're gonna talk about the schedule AI workload among multiple clusters. It's a GSoC 2024 project. We've been getting a lot of interest from the community on this issue on this topic, so it's great. Queen Hao is gonna talk a little bit about it later. But before we get to that, Q Jang is going to share with us the cluster API integration. I guess a demo that he mentioned in the last community meetings. The cluster API or integration has been something the community have been asking for quite a while. So we're very excited to see this demo. Q Jang, please feel free to take it away whenever. Thanks.
Okay, yeah, let me share my screen. Yeah, I like to demo about some integration with Capi that I have done recently. I create a new project in my own GitHub account, which is called Importer, uh, and it is going to uh automatically import a class copy clusters into the open class management. Um, so this is a project, the copy importer. So to start that, currently I need to specify a Bootstrap service account. This service account is using to generate the Bootstrap secret and the Hub API server. Uh, the address of the Hub API server and the CA cert of the Hub API server. So that's yeah, that's all. Then we can start that. Another thing is currently this one need to this in controller need to be um run in the same cluster with OCM and copy cluster provider. So let me give you the. So currently I have one cluster. I have one clusters. In these clusters, I get copy installed and I have the OCM hub installed. For the copy, I will use capd, which is to start a controller, simply start a cluster using the Docker command in the local machine. It's only for development, but in general, this importer should be able to be used to auto import other clusters in different cluster provider. So let's first start this controller, and then I will create a copy cluster using this one. I have the YAML to start the clusters in class API already. This is a single one cluster with only a control plane to make it simple. So I will create this one, and you can see the clusters is provision. So it will take some times for the controller for the class API to generate this kubeconfig. And the importer we use also will use this kubeconfig to import the clusters into the hub. So now as you can see that this cluster is the secret is generated. the kubeconfig is generated here, and then the importer will use that kubeconfig to start the classlet and deployment, the classlet operator deployment in the managed cluster, and then we can visit the managed cluster using this one. I get the kubeconfig of the managed cluster, and then let me use it. Yeah, so I can see the so we can see that there's a classlet operator classlet deployment that is deployed in this managed cluster that is started by the cluster API. But the current problem is that in this cluster that is initiated by the copy, the networks plugin has not been installed. So we also need to install the network plugin. We install the network plugin in this cluster. And also because it's a single node cluster, we need to remove the tint on the control plane node. Let me first get this. So you can see that control plane node is ready. We need to remove the tint. So our classlet operator and classlet agent can be running in the control plane node. Remove the tint. Okay. And let's take a look at this one here. So you can see that the agent is started. So back to the, so let's wait for a minute. Okay, and then if we back to the management cluster, we can see that one cluster is registered. So the next part is just to accept that.
Cluster admin.
Sorry.
No, this is good. This is a live demo.
Yeah, so it will take some time to become available. Yeah, and that's all for this demo. So the main part is just the importer controller here will going to read the kubeconfig secret that is provided by the copy provider, and then use that to deploy all the classlet resource and operators onto the manage the cluster. And then the other part is just the similar as what we did for the cluster registration. That's interesting because that kubeconfig is kind of like a standard way that copy provider, no matter what kind of provider, will always provide the group config in that namespace. In the same namespace of the cluster resource and with a certain format of the name. So, which means that no matter what kind of the copy provider we use, like the AWS, JK, etc., we should always be able to get that group config and start the cluster. So yeah, I think that's all for this demo.
That was really great, Kishan. For that cube config is a short-lived one, or how long does it last?
So I think currently it's a long-lived group config. Can take a look at this. I think that is based on the different provider.
Okay, thank you.
In the copy Docker implementation, it's a client cert. So in this implementation, I think there's a long-lived group config.
This importer, is it generic enough? I know you did it on kind of like a local dev cluster, but if it's EKS, AKS, or whatever, is it still gonna work?
I mean, we bootstrap AKS cluster or the hub is AKS.
I mean the cluster API. Yes, you are. I mean, assuming or real cluster. That's what I mean. Like if it's any other flavor of cluster, if the hub and the cluster API all lives in the same cluster, is it? And then you create a cluster full cluster API. Let's say a let's say AKS cluster.
Mhm.
Does this importer already work, or is there some extra work that's needed?
So as long as for example, if the AKS class provider can provide this secret, provide this kind of secret in this namespace, it should work. Commonly, it will provide, like I check the cluster API document, and it doesn't say it's a standard, but it actually has a comment like cluster CTL get group config. And this one is basically to read the cluster name and read the cluster name -- group config in the same namespace and return the group config in this to let user to access. So I think that is quite a common way that every class API provider will do the same things to
So
provide config in this namespace.
So is that the thing that you're watching for, the Q config, or you're watching for the cluster API CR the cluster, or
Yeah,
both?
we watch for the class API CR, like this one. We watch for the class API CR. So there is a condition like whether control plan is ready. So the current situation is even the provider itself, it will use this group config to access the control plane to check whether the control plane is ready or not. And so if the control plane is ready, it basically means that the kubeconfig is in that namespace already. So when it's ready, we should be able to access that secret and use that secret to access the managed cluster.
But can we do something? I know that I'm getting really ahead. This is really great already. But you know how you had to untaint the worker node because it was tainted. I guess for local development, they taint it as a starting point. But is it possible for us to go like, oh, we know now that you actually have worker node. Now you can actually, have our agent be provisioned. Can we do something like that, or do you think it's not necessary?
Um, yeah, that's a good question. I'm not sure. Maybe I need to dig more about that. So the weird thing of the CAPI provider today is, when you use a CAPI to bootstrap a cluster, there's no network plugins. So it will not automatically install a network plugin. Maybe for some other providers, they will provide a default network plugin, but not for everyone. So if there is no network plugin installed when the cluster is bootstrapped, every node is not ready. So even though you create a deployment into that node, you don't know, we cannot know whether, like, we don't know whether it is possible. We don't know whether the pod can be running. So yes, maybe we should, before we import, we need to check the cluster whether, like, it is ready for deploy the agent.
Yeah, but maybe for the future. But
Yes.
and another thing, what about when it comes to like deleting the cluster? If it's deleted, what do we do? Do we do anything? Like or just do everything on the hub side?
Deleting is so I think if we have already, so currently deleting is really simple. Like, you just delete clusters, and then the underlying clusters will be deleted, and you can delete the managed cluster.
Oh, yeah, what I meant was, does the managed cluster delete automatically? But it's okay.
Oh no,
It's just,
no.
yeah.
But that here's a tricky part. Like, so currently there's no workload running on the managed cluster, but if there is workload, I don't know. I mean, if, for example, some manifest work or add-on that is already running on this cluster, we need to find a way to clearly remove the workload before deleting the before allowing user to delete the cluster.
Got it. Okay, sorry I have so many questions, but this is really interesting as well. No, this is really good.
Thank you.
Anyone else have any other questions for Qiu for his amazing live demo, cluster API, and OCM integration? If not, I'm gonna hand it to Quinn Hao to talk a little bit about the AI workload scheduling that has been gathering a lot of community interest. Quinn Hao, please feel free to take it away.
Yeah, thank you, Meg. I will share the screen. Sorry, there is some issues with my screen sharing. I need to quit and rejoin. Just wait me for a few minutes.
Yeah, well, I can share this. Oh, okay. Please rejoin. Yeah.
Oh, yeah, feel free to share it for me.
Okay. Okay, I close it. Give me 2 seconds. Can you see the screen?
Yeah, thank you. So this is a project we submit for the Google Summer of Code in this year. And if you, yes, please help open the first link. Also, we submit our idea under the CNCF organization. CNCF joined the Google Summer of Code as the organization, and we submit our idea under it. Or you can see the open class management in this page. This page is an idea list. And also, if you go to the up of the page, you can see there is a timeline for this project. Yeah, this one. I think if you have interested to contribute to this project, you need to take care for this timeline. Till next Monday is the time you can discussion with us, with the mentoring organization. And from next Monday to the April 2 is the time for the contributors to submit your application. And after that, I think the Google Summer of Code will do the ranking for these proposals and select one to be the final one. Also, if you have interest, feel free to discuss it under our issue or in our Slack channel. I think we already have a few students join the channel and raised their questions. Okay, that's a background. Now I will talk a little for this project.
Yes.
There is already a few discussion for the question for this project. And for this project itself, the topic is to scheduling AI workload among multiple clusters. So as you know, for our open cluster management, OCM, we focused on the multi-cluster and multi-cloud management for the Kubernetes applications. And we have a concept called placement. The placement is used to dynamically select a set of clusters so that you can either replicate your Kubernetes resource to the multiple clusters or run your workload to the multiple clusters. For example, if you are an application developer, you can deploy your workloads to the clusters with most allocatable memory and CPU by placement. And also, so this topic is for the AI workload. As a rise of the AI technology, we received some requirement to schedule the AI workload based on the GPU and the CPU resource. So in this project, we want you to learn about the placement extensible scheduling mechanism and hope you use it to implement a GPU or TPU resource collector by the OCM add-on template, and also want you to provide an add-on placement score so you can use it to make the placement decision based on GPU and TPU. And at last, we want you to learn about the queue. Queue is a Kubernetes native job scheduling project. We want you to use the queue's external automation check controller mechanism to consume our placement decisions so that you can schedule the AI workload among multiple clusters based on the TPU and GPU. And the expect output is that first we want you to develop a GPU or TPU resource collector add-on. That is, you will contribute your final add-on to the OCM add-on contribution repo. And another thing is that we want you to learn about the queue automation check controller and provide a proposal to outline the API design and how your controller can consume the OCM scheduling results and interact with the queue. With that proposal, you can let it reviewed by our community, and you also need to deliver a proposal based on your deliver a prototype based on your proposal. Okay, that's the expected output 2 point for it. And under the list of this issue, I list a few reference about the OCM, the placement, the add-on, and extensible scheduling, and the add-on template. If you have interest, you can learn about it. And also, last is the discussion. Feel free to raise your question in the GitHub issue or join our Slack channel so that we can better help you to understand this project. I think that's all for this.
That's great introduction, Quinel. Yeah, we're thinking maybe we can talk more about it in the next community meeting, depending on how it goes, and see if we can invite some of the people who are interested in this project to join as well, so we can discuss and ask live some of the questions they have. But yeah, thank you so much, Quinel, for the quick intro. Any question for Quinel? If not, thank you everyone for joining today. Please take care. Thank you.
Thank you.
Bye.
Bye.
Thank you. Bye.